distance. So let's begin with the word motion. What do you understand by motion? Motion, meaning of it in itself. Okay. Opposite of motion word is what rest. So before this discussion, let's understand about motion. Look, buddy, we have a object. Okay, we have a object. But here is a book. This is book. This is book. So its position is changing after applying a force. After applying a force. So if its what movement of book is changing in any direction, so it is in motion. It is in motion. It happened because of motion. So we move something. So that process is known as motion. Clear? So position of this book is changing because of by applying force. So we apply force to change this position. So this is a context of a force. So to move anything, we apply force. So its position is changing by applying force. So it is a motion. Clear? Similar. So here we apply external force. We apply external force to move it. Whether we are apply external force if we are not applying external force, but it is in motion. It is moving. Moment of it book is moving, then it will be known as motion because it is in moment position. It came from here to here, so it happened. What this shows what motion rest. This board is it a board motion or rest? Something is in motion. Object is in movement. Those objects is named motion. Something is moving. Something is moving automatically. You can say otherwise by external force. So those moving objects is named as motion. But whereas a lot of objects are not moving by neither by external force nor automatically. So those types of objects will be named as rest because there are a lot of objects in the world which are which can't move without applying force by human by an object. So this board is in a rest. This board can be moved. Can be moved. If we are moving this board, then it will be known as this is in motion. There are a lot of types of motion. There are a lot of types of motion. So just in this context, we need to understand what something is in something is moving, something has changed those position. So that process will explain about motion. But whereas nothing, we don't see we don't see any type of change of a object. Those objects are in rest position. So that's why those objects are named as rest. Clear? So this board is in a rest because it is not moving. We are not moving this board. Okay. Next, let's try to understand measuring length. non-standard units and standard units. Non-standard units, standard units. What is meaning of it? What is meaning of it? We should have standard units from which we cannot confuse. We cannot be confused. In ancient times, non-standard units. In ancient times, non-standard units used to use by human parts. Those people, earlier people, wanted to measure its size of board. They used to apply what hand part to measure it, to make it in another shape. So those humans used to apply what hand part to measure it. But earlier, those humans realized what we should have standard units. Gradually, standard units came into picture. Today we have standard units. We are using it as well, and it is compulsory because we should have to have standard unit. And what are those standard units? We will try to understand. Meter, kilometer, Pascal, Newton. These are standard units to measure something. Okay, kilometer can be used to measure a road, to measure a long, uh, long lengthy area. Meter can be used to measure a small area. Pascal is used to measure pressure. Okay, like this, so on. So we have what some standard units from which we can measure something. The basic, uh, the basic unit, the basic unit of length is what meter. The basic unit of length is meter. So we know 1 meter is what 100 centimeter, and 1 centimeter is equal to 1 meter is equal to 100 centimeter. 1 millimeter is equal to 1 centimeter is equal to 10 millimeters. Millimeters, and 1 millimeter is equal to 1 kilometer is equal to 1000 meters. This is how we can see standard unit of length is what we use a meter to measure a. We can use a meter to measure it this board, whereas we use centimeter, millimeter to use something little thing. little thing. Okay, centimeter we use to measure a little thing. Uh, Advanced things we can use this meter. Advanced things to measure. Advanced things we can use meter. Uh, Whereas highly, widely, and highly lengthy material we can measure by kilometer. This was uh, this was standard unit. Let's come let's come on types of motion. Let's come on types of motion. We have a lot of more types of motion. Rectilinear, rectilinear. What do you think? Rectilinear, rectilinear motion. What would you like to say regarding this motion? What is example for this circular motion? Then we have periodic motion. Rectilinear motion, circular motion, periodic motion. Motion along a straight line. Let's understand this by a practical example. Car is moving on a road in a straight. This car is moving in straight line. These cars are moving with along a straight line on a plain road. That's why this car is moving, which is said rectilinear motion. Okay. So this car is moving with along a straight line. That's why this type of motion is named rectilinear motion. Circular motion, circular motion. Bike. This is a circular shape, circle shape. That's why it is said circular. But something is moving, or something named object is moving in circular shape. So this is motion, but this motion is named circular motion because it is moving in shape of a circle, in shape of a circular. That's why this type of motion is named as circular motion. Periodic motion. Periodic motion. Meaning of a periodic motion is simple, but motion, same moment is repeating again and again after completing one motion. This is object. This is object. Okay. He goes to here. Then again uh, comes back. Then goes here. Then again comes back. Then goes to here. Then again comes back. So this is a repeating motion. And this type of repeating motion is named as periodic motion. And this type of motion is seen in watch, in wall watch, in wall watch. So definition of a periodic motion is motion which repeats at regular intervals. So those types of motion would be named as periodic motion. So rectilinear motion, any object is moving along a straight line. So those objects, those motion will be named as rectilinear. But whereas a object is moving with a circular shape, so those that is motion, and those motion is named as circular motion. Periodic motion. So periodic motion says I will repeat again that moment, same moment. Then again I will repeat same motion. So periodic motion which repeats the same motion after internal time. We understood here types of motion. Types of motion. We are moving. What is meaning of rotational motion? Rotational motion. What is meaning? Rotational motion. Our Earth is rotating. Our Earth is rotating with around a planet, around a sun. Our Earth is rotating. Rotating, which means what? Around a fixed axis. Rotational motion, it's like a circular motion, isn't it? So it is saying means a axis is fixed to rotate a object. For example, Earth, our Earth is fixed to orbit. So Earth is example of rotational motion because motion of Earth is fixed. So those types of fixed motion is named as rotational motion. Let's understand about the speed. About the speed. Speed. A bus, a car travels from here to till here. How many kilometers? How many is a kilometer? 50 kilometers. So this total distance is what a speed. This is total what distance 50 kilometers. This is not a speed. Okay. A speed if we need a speed then after calculating we would have what kilometer per hour. Numerical with kilometer per hour. Numerical with what magnitude with the unit. So here 15 kilometer our car traveled 15 kilometer distance Our car covered how many? 50 kilometer distance within uh, 30 minutes. 30 minutes. Now we will get how many distance at 30 minutes. We have time. So distance is 50 kilometer and the time is 30. So approximately 1.8 kilometer per minute. Per minute 1.8 kilometer. Per minute 1.8 kilometer is being covered by a car per minute. Uh, how many kilometer? 1.8 kilometer is being covered by a car. Got it? By a car. So meaning of this is what 1.8 kilometer a car our car is covering distance with per minute. This is a speed. This is not a distance. Distance is we have what 50 kilometer and this is a time. Within 30 minutes, our car traveled how many? Our car traveled distance how many? 50 kilometer. 50 kilometer. Okay. And this car was moving with a speed of 1.8 kilometer per minute. Got it? This was the calculation. Numericals. This was numericals. Let's understand distance and displacement. Let's understand distance and displacement. Distance and displacement. Distance and displacement. What is the meaning of it? It is very easy. It is what basic for our mathematical of physics. Distance is what this is object. Okay, this is object. So this object has covered distance. Has covered distance. How many? How many? 14 kilometer. So this 14 kilometer is a distance that has been covered by this object. So 14 kilometer is what distance. Whereas after this after 14 kilometer covered by our object, then it moves from here to till here. Now this object covered how many? Uh, from here to till here, 15 kilometer. Now what is the distance of this object? If we need a total distance, then we will add. It's very simple. Total 14, 15, 29. We have total distance how many? 29. Because we want a total, that's why we added both covered distance. Now we have how many distance? We have 29 kilometer distance covered by an object. Displacement is what? Initial point and final point. A object from here to till here goes. This object goes from here to till here. This was initial point. This was initial point, and this is the final. From here to till here, our object achieved. Our object received here after covering with the covering distance of 16 kilometers. Got it? So initial is we have 0 kilometer. Something is moving from their position to another position. So now remember that distance will be always in positive, but displacement could be positive or negative. It covered how many? 16 kilometers. And now object is here. That's why it is a displacement. But whereas it comes back how many? 5 kilometers. Now what is a displacement? How many is a displacement? We have how many? Only we will subtract it. We will have 11 kilometers. Okay, 11 kilometers. 11 kilometers. So here, if we see distance, how many have we distance? We have 21 kilometers. We have distance is 21 kilometers, but displacement is how many? 11 kilometers. Because of this object came back. That's why it is considered as a displacement. As a displacement. Try to understand here. This is object. Here is a object is moving and moved to till here. This distance is 20 kilometer. Then it turns into another direction. That is what vector. So it turns into another direction with the 15 kilometer. Now we need to find out displacement and distance. So we have a total distance how many? 35 kilometers. This is a total distance, but displacement would be this is a displacement. This is not a displacement. From one point to last point. This is initial point and this is final point from the perspective of a displacement. Now we have 20 kilometer. This is known as hypotenuse. 20, then 15. 400, like this. Okay. Then we will rotate. Then we will have exact kilometer, exact distance of this. This is a process to find out to calculate displacement. So remember what this distance always would be, always will be positive, and displacement could be what negative also positive. Displacement is a vector, and distance is a scalar, because distance is covered with quantity, not with direction. Car is moving, so car traveled how many? 15 kilometers. So here car is not giving direction. Okay. Whereas a displacement is a vector which gives us magnitude, quantity with the direction. Okay. So that's why displacement is a vector. Displacement is vector. This was a process from which we can calculate the distance of the object and displacement of an object. Graph motion. Graph motion. We understood rectilinear motion, circular motion, periodic motion, rotational motion. It's a time to understand about the graph motion. Already you know what a graph motion will say. Your motion is a changing, which means acceleration. Your object is accelerating. Accelerating. So here graph is like this. So our motion is a constant. Our motion, our object is with constant motion. It is not accelerating. Whereas motion of an object is like this, like this. So here this shows what your object taken as read. Your object accelerated. This is how our graph shows us motion and object. So our car covered a distance by like this motion. So our car accelerated. So accelerated, which means what we are increasing motion of our object, and where we need, then we are decreasing our motion to stop our car where there is a traffic, there is a what, something wrong there. So it shows what our motion we are increasing, we are decreasing. Motion is being decreased by us, motion is being increased by us. This is graph motion shows us, and this is how which explains about accelerating. The rate of velocity, the rate of displacement, the rate of velocity is what accelerating is acceleration. When it comes on topic of acceleration, we will try to understand about acceleration. Okay, but whereas our car is going like this with this motion, so it is saying our car has not changed a speed. With the same speed, our car is going. With the same speed, our car was moving. Got it? Can we move to the next? Now you have a uniform motion and non-uniform motion. How would you explain it? Try to explain it. Can you explain it? It is very easy to explain it. From this word, we can explain it easily. Uniform motion and non-uniform motion. Uniform with the same motion is moving. An object is moving with the same motion. This is object. This object is moving with 60 kilometer per hour, and this is a continuum with an hour. Then this motion will be uniform motion. There should be two things: this object and this object. Both this object is moving with the same speed, which is let's suppose speed is 60 kilometer. This object is moving with the 60 kilometer, whereas B object is also moving with the 60 kilometer per hour. So this motion is a uniform motion because both motion is in same is with the same motion with the same speed. That's why. Whereas we can say what this is moving with the 60 kilometer and whereas this is moving with the 50 kilometer per hour. So of course B would be back and then movement of a object because this object is moving with a 50 kilometer per hour speed, but this with 60 kilometer per hour. So this speeds that shows what this motion is non-uniform motion because both objects are not moving with the same speed with the same speed. So any type of motion, but those motions are moving with the same speed. So those motions will be kept as a category of uniform motion. But whereas uh, two objects, but one object, there are two objects, but one object is moving with a 50 kilometer speed, 50 kilometer per hour speed, but second B object is moving with 10 kilometer per hour. So this is shows what this is non-uniform motion because a speed is not the same. So non-uniform motion says your speed would not be same with the two object. With the two object. So here we understood what a speed, velocity. We are going to understand about it. Velocity. We understood here what uniform motion and non-uniform motion. A speed, which means the distance covered by the object and time taken by time. Taken time, okay, and covered distance by an object. When we will divide it, then we will have a speed. How with how many with a speed a object is moving. Velocity, it says that displacement of an object and time. And time. Displacement of an object. Time is compulsory. Time is compulsory. So definition of a velocity is what? The rate of a displacement is a definition of a velocity. So a car has a covered displacement within a 10 minute. So our 10 minute is the time. Displacement how many? 15 kilometer within 20 minutes. So we would have so 2.1 kilometer is being covered by a object with per minute. Within a per minute, 2.1 kilometer covered by an object. This is how to calculate a velocity. We know distance is what? Total distance. But displacement is another thing. That's why we are calculating in other way to calculate velocity. So velocity is another thing. When we say velocity, then in our mind will come displacement. But a speed, then not a displacement in our mind will come. Okay. Let's understand about acceleration. Acceleration. Already we tried to understand about acceleration. 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 The rate of the rate of change of a speed. The changes of a speed is called acceleration. It could be by external force. Yeah. Our speed is increasing. Then after some times our speed is decreasing. After speed is increasing, then after speed is increasing. This is acceleration of an object which is moving sometimes faster, sometimes slower. So it happened because our object forced sometimes more, sometimes less. The rate of change of velocity of an object. The rate of change. This is changing in a sphere of an object. That's why we are saying what the rate of change of a sphere of a velocity. You can say when we say velocity, we are describing a displacement. Let's find out the formula of acceleration. Final velocity minus initial velocity by time, which means displacement by time. displacement by time. You can velocity by time. Okay. So we represent displacement by v and time by t. This is acceleration. This is acceleration. Got it? So here we will get what a total displacement, which was changes of a speed. This was acceleration. Here try to understand what through graph motion. This a object is moving with 60 kilometer per hour. So it is it is not changing direction. It is not a changing direction. This is with same 60 kilometer speed. 60 kilometer per hour speed. That's why it is indicated by a uniform motion because it is a same. It is a with the same speed. But whereas our line is like this. Sometimes our object moves with 60 kilometer per hour. Sometimes our object moves with 40 kilometer per hour, which explains our speed of a object is decreasing. Okay. So here this is what non-uniform motion because it is not the same. Our object is not moving with the same speed. Our object is moving sometimes uh, with 60 kilometer speed per hour, with 40 kilometer per hour. So it is a changing of speed of an object, which is a meaning of a solution. A solution. A solution. Got it. A solution. Because our object takes speed sometimes low, sometimes high. Got it? Yeah. So this is also a solution. This is also non-uniform motion. Indication fonts always keep remember what U, V, E in this context. U is the first letter coming in for alphabet. That's why it is initial velocity. Whereas this is a final velocity. And A stands for acceleration. So we represent the initial velocity by using U word. We represent the final velocity by using V, and we represent acceleration by using A letter. It will come in our mathematical in numericals. First equation and second equation. There are three equations. Do you have any idea regarding this? That's why our eyes are able to see the object because of light is falling on surface of object. Clear? So light helps us to see the objects. Clear? Through example, let's understand. This is what this is book. Got it? This is book. So in word, in a noun word, we say it what? Object. We say object. So object definition of object would be what? We can touch those materials. We can see those materials, those things. So are we be able to see this object? Yeah. We can we touch this object? Yeah. That's why it is object. It is named as object. But name of this object is what? Book. Clear? Now to see this book, what do we need to do? And our surrounding should be what? Source light, so that light will fall on this object. Got it? This is a source light. So here one is a compulsory source light. Second, you can see object. At least minimum two things are compulsory. Two things are compulsory to see anything. So we are here. This is object. We are looking because this light coming from source light is falling on this, and it is getting reflection, and this reflection is entering in our eyes. That's why we can see these objects. That's how we are able to see any object, to see any object. Got it? This was a definition of light. So light provides us ray, beam, beam, luminous objects. So first of all, you need to be clear what this is object. So now we need to identify which type of object would be what luminous object, and which type of object would not be luminous object. So let's try to identify that which type of object would be luminous object. So definition of it is anything, any object, if those objects have their own light, those objects can emit their own light, so those objects will be kept in the category of luminous objects. Clear? For example, torch. This is a torch. Torch has their own light. Sunlight also has their own light. Sunlight can emit their own light. Torch also can emit their own light. That's why it is a definition of luminous objects. So these are examples of luminous objects. What nature light, about nature light and artificial light? Do you know some little bit information about the nature light and artificial light? Can you explain it? Nature light, which means uh, which means it is not made by human. It is not made by human. It is made by nature. It is made by nature. So this type of light so cannot be made by us. Cannot be made by human being. That's and nature lights are sunlight, stars. So these are nature lights. Artificial light, artificial light, artificial light. So these lights, what? These lights is made up by us. Is made up by human being. We can make artificial light. Whatever we are making light, we are creating light. Those lights will be known as artificial light. Those lights will be named as artificial light. That's why there are two names of light. One is natural light, second is artificial light. So both light will come in the category of luminous objects because both these lights have their own light. Both these lights can emit their own light. That's why those types, this this types of light is named what luminous object. Let's see about non-luminous object. Non-luminous object. So here we are identifying which type of objects would be non-luminous and would be luminous object. Got it? So as we saw, what luminous objects would be those objects which can emit their own light, which will have their own light. But whereas if we understand about non-luminous objects, so those objects, except objects of non objects of luminous objects, those objects which don't have their own light, any type of light, those objects which don't have their any type of light. So examples are this board, this light. We are examples of non-luminous objects. House are example. House is an example of a non-luminous object. This window would do anything that cannot emit their own light. Those objects will be named as non-luminous objects. Clear? Uh, Now it is very interesting. Okay? And it is a scene as in real life. Still, we are going to identify which type of object would be transparent object and opaque object and translucent object. With the definition and with a practical example, we will try to understand it. Okay, transparent object. Yeah, this is object. Let's suppose this is object. We don't know because it is a transparent object. That's why. So it is object. Clear? Now, to see these objects, we need what? Source light. We need source light. This is a source light. This is a source light. And light is coming from this source light is falling on this object, and it is passing through this object. It is passing through this object. So this object is saying, I am what? Transparent. Because you are here and the area behind me you can see. So it is happening because of like this, it is happening because of I am transparent. I am giving allow to pass the light from one side behind me to behind me. So light is passing through object. That's why it is named a transparent object because of light is a passing through the object, through the object. And other on other word, we are able to see behind area of this object because of light is passing through this object. That's why we can see area behind this object. Those objects that allow to see area behind of that object to us, then those objects would be transparent. So here we can say light is passing through the object. That's why it is a what, transparent object. Here, if this light is not passing through this object, rather it is turning into another direction. It is turning into another direction, and this turning, this changes light is coming in our eyes, into our eyes. This is entering. This light is entering into our eyes. That's why we see this object, and it is turning into another direction, which means light is being blocked by this object. It is turning into another direction, which means light is being blocked by this object. And if light is being blocked by this object, so it, this object is saying, I am opaque object. I am opaque object. Clear? Because light is being blocked. It's all about light. If light is passing through the object, then those objects would be named as transparent. If otherwise the light is not passing through the object, then those objects will be named as an opaque object. If something light is being blocked by the object, whereas something light is passing through the object, so those objects would be named as translucent. So it's all about light. If light is passing through the object, then those objects would be known as a transparent object. If otherwise, on the other hand, light is being blocked, light is not passing through the objects, so those objects would be named as opaque objects. If something light is being blocked, whereas something light is passing through the same object, those objects would be named as what, translucent object. This was in written form. So here we understood through practical example about a transparent object, and about opaque object. It's a time to understand about a translucent object in practical example. So here light is being blocked, light is not passing through this object. That's why it is saying I am opaque object. Clear? Light is turning into another direction because it is opaque, and if a light is getting reflection, that's why we can see shadow of this object because of light is turning into another direction. Light is not passing. That's why we are saying what shadows are formed behind the opaque object because the light gets reflected. That's all. Clear? Here, when we were understanding about a transparent object, so here light is passing through the transparent object, so here there would not be any type of shadow because the light is passing. Whereas the light is not passing, then shadow will be formed behind the object. Clear? And those objects will be opaque object. Something light will be blocked and something light will not be blocked. Something light is being blocked and something light is not being blocked. So uh, those would be known as translucent object. Clear? So area that is being blocked by light, that behind that area will be formed shadow. But area that is being blocked, that is not being blocked by light, those area will be blind, will not be of shadow. Clear? So transparent object, example of a transparent objects are what, glass, window glass, door, and example of a translucent object, blur blur glass window, blur glass door. Got it? Then examples of opaque objects are a lot of a lot of this wall is a example of opaque object. I am an example of opaque object. Light is coming from source, light is falling on me, and behind me is what, shadow. Shadow is there because of light is falling on me, and it is getting reflection. Light is being blocked by me. Light is being blocked by me. Light is not passing through me. That's why there is a shadow behind me, because of light is not passing through me. Clear? We are example of object. Let's understand here about shadow, size of a shadow, shape of shadow. So here, if this size will decide uh, when light. So size of a shadow of object will be decided when source light. If a source light is near in front of object, then shadow will be what, uh, in a small form, in a small form. Whereas source light in front of object, in front of opaque object is far away, then shadow of that of the object would be in larger form. So it's all about to keep what source light between object and source light. Clear? Let's suppose this is source light is falling on here. I think it's enough. Shape. Shape. If size of a shape of a shadow is large, we understood about. So shadow gives us additional information of light of reflection. Sometimes we see, but we cannot explain that this shadow is of animal, this shadow is of a is of that object. We cannot explain. It means shadow will not explain that this is a shadow of original object. No, sometimes we can see like this. Shadow rainbow color of a shadow is what? Color of shadow is black. Black. Okay, black. Color of a shadow is black. Reflection. Shape of shadow we understood, we saw, and we saw what the size of shadow. Let's understand a reflection. Let's understand a reflection. Here we can understand. Okay, we can understand reflection. Do you have any idea, any information regarding reflection of light? Do you have any idea? Can you explain it? Uh, let's try to explain it. This is a reflection. This is a process that is saying what it is getting reflection. So here, try to understand. Source light is compulsory, and on one side opaque object is compulsory. So here we are looking what light is falling. This is incidence. This is incidence ray. This is ray, but it is a not ray. It is a beam. Then we can say rays. This is incidence rays because this light is coming from source light. That's why it is a said incidence. But this light will hit on an object and it will turn into another direction. This change light will be known as reflected ray. Clear? Because reflection ray explains what about changes of light. It changed into another direction. It turned into another direction. So changes of direction of light is what reflection ray. Clear? So here, mm, this incidence ray, here we are looking what I letter. So first I letter, it is represented to explain incidence, I letter. Whereas this R will be represented to show reflected ray. Clear? So I think let's understand if it is possible. So here, this straight line will be what? This straight line will be known as normal. Normal line will explain what if incidence ray is what incidence ray uh, what. So here angle of incidence ray would be same, would be equal to the reflection ray. How? Because it is falling on plane surface. That's why we are looking what incidence ray is equal to the reflected ray because of it. This incidence ray is falling on plane surface. That's why on plane surface with the smoothly clear. This is let's suppose 45 degree. Then also angle of reflection ray will be 45 degree. It is saying what both will be equal. Clear reflection. Let's see more about the reflection. We are in front of a mirror. We are in front of a mirror. Got it? Here. We are looking our image inside mirror. So it's all about because of there is a light in our room is falling on this or on a surface of a mirror and it is getting reflection. It is a turning and is coming in into our eyes. So this getting reflection is falling on us body. Then it will turn into another direction like this. That's how our image are formed. Our image is formed inside mirror. This is how to form a reflection of the object inside mirror. Should be one thing should be there should be one thing what source light. Source light of source light will fall on surface of mirror will turn into another direction. That directed ray will hit on us body. Then again directed ray reflected ray will turn into another direction. This is a process which forms what our duplicate image inside mirror. So here behind this mirror, we see what painted area with a silver paint. Because of painted area is that is not giving allow to pass this light. That's why it is said mirror is opaque object. So remember that mirror is opaque object because behind mirror is a painted area with a silver. It helps to stop what it helps it don't does not allow to pass the light. Clear. So laws of reflection we understood here. What angle of incidence ray is 55 degree. Then also angle of reflection ray will be 45 degrees because of incidence ray is falling on plane surface. That's why we are looking what both angle degree is the same because of so here this normal line is imaginary